Good day! Welcome back to SMAPI Mathematics Club video channel, the tutorial and educational video program in the field of mathematics in junior high school. In this video, we are talking about the introduction of patterns and sequences. A preparation for your first lesson in grade 10 on first quarter, which will be able to demonstrate understanding the key concepts of generating patterns and sequences. Before you watch this video, you can like, follow, and subscribe our YouTube channel of the SMAPI Mathematics Club. And if you like to watch our video on Facebook, you can like and follow the official Facebook page of the SMAPI Mathematics Club at www.facebook.com/SMAPIMathClub. Let's start! Today, students, we will have our short drill before we start our tutorial problem. You will figure out what will be the next figure in a given set of elements. Let us start with the first set of elements. What will be the next figure? Alright, the correct answer is diamond. How about another set of elements? What will be the next figure? Alright, the correct answer is right arrow. How about the last set of the given elements? What will be the next figure? The correct answer is 10, because let's keep counting numbers by 2, which is 2, 4, 6, 8, and the next pattern would be your 10. Based on the following set of elements earlier, what did you notice about this set of elements here? Alright, this set of elements which illustrate the patterns and sequences. Today, we will work with patterns. Recognizing and extending patterns are the important skills needed for learning concepts related to generating a sequence. Let us discuss the introduction of generating patterns and sequences. Do you have any idea about patterns and sequences? Alright, so let us discuss about the definition of these two terminologies. What is pattern and sequences? A pattern is a form or model proposed for imitation. It could be oscillating, logical, and repeated over and over again. While a sequence is a set of elements, objects, numbers, or any kind of such things can be arranged in any specific order. It could be generated from shapes, patterns, or rules. A number sequence is a list of numbers having the first number, the second number, third number, and so on and so forth. All are the terms of the sequence. In number sequence, it could be in any specific ways like increasing, decreasing, oscillating, and repeating order. Each number in the sequence is what we call a term. Each term is identified by its location or position in the ordered list. It is usually denoted by letter A, which is a term, and with a subscript that represents as a number. So that is A sub 1, A sub 1, A sub 2, A sub 3, so on and so forth, so that are forming any kind of sequences. For example, given the sequence 400, 200, 150, and 25. So we could identify what will be the first, the second, the third, and so on, depends on the ordinal number of their location of every term. So let us start with the first term. So, what is the first term in a given sequence? Alright, so the first term that represents as A sub 1. So the A sub 1 would be the first element of the given set of sequences. So that is 400. So the A sub 1 is 400. Next, what is the second term? Okay, correct. The second term is 200. So the second term represent as a sub 2 is equal to 200. How about the third term? The third term that represents as a sub 3 is equal to 100. A sub 4 would be the next term is equal to 50. And a sub 5 is equal to 25. So the first 5 terms in the given sequence is 400, 200, 100, 50, and 25. Take note, the expression a sub n is used to represent the nth or the general term in a sequence, where n is any positive counting number which every term will represent its ordinal number. It depends on their specific location or the position of the terms of the given sequences. Here is the first example. Find the next two terms of the given sequence are 5, 8, 11, 14, so on and so forth. Our solution is, so in the given sequence, 5, 8, 11, and 14, so we have to add 2 blanks here because we are looking for the next 2 terms. Next, we observe that in a given sequence, so which has added by 3. A term is obtained by adding 3 into the previous term because the common difference of 5 and 8 is 3. What is the difference between 8 and 11? It's also 3. What is the difference between 11 and 14? Yes, it's also 3. So, a term is obtained by adding 3 to the previous term. So what we're going to do is to add 3 to the previous term. So the previous term, that is 14. So 14 plus 3 is equal to 17. Next, to find another term, so same repeating process. So 17 added by 3 is also equal to 20. Therefore, the next 2 terms of the given sequence are 17 and 20 respectively. Did you get it, students? Students, the next example is, find the next 4 terms in the given sequence are 7, 14, 28, and 56. Okay, so students, what we're going to do first is you have to add how many terms are there. So, 4 terms. So we have 4 terms, you have to put 4 blanks here. Okay, next. What did you observe in this given sequence? Yes. So the given sequence that observed are twice of every sequence. We notice that 7 times 2 is equal to 14. 14 times 2 is equal to 28. 28 times 2 is equal to 56. So, to find the next term, to represent the blank, the next sequence would be a sub 5. So a sub 5 would be the 5th sequence. So our previous term is 56. So 56 multiplied by its common ratio, that is 2. So 56 times 2 is equal to 112. So a sub 5, which is 112. How about the next term? So the next term would be a sub 6. A sub 6 is equal to the previous term is 112. So 112 multiplied by its common ratio, that is 2. So what is the product of these 2 numbers? Correct. So that is 224. How about the next term? So the next term that represents as the a sub 7. So a sub 7, what is the previous term? Okay, right. So that is 224. So 224 multiplied by 2 is equal to 448. How about the last term? So the last term would be a sub 8. So the 8th term, which is the previous term, is 448. Multiply again by 2. So 448 times 2 is equal to 896. So 896 is the 8th term. Therefore, the next 4 terms in the given sequence are 112, 224, 448, and 896. Did you get it, students? Students, let us discuss another example. What we're going to do is to list the first 4 terms of the general equation, which is a sub n is equal to 3n squared minus 1. So what we're going to do is to let the value of n that represent as the nth term. So where n must be a counting numbers, which is the first 4 terms starting from n is equal to 1 to 4. Okay, so there are only 4 terms that will be needed to manipulate this general equation or rule. So let us start with n is equal to 1. So if n is equal to 1, so we are going to use the general equation, which is a sub n is equal to 3n squared minus 1. So substituting the value of n, it would be a sub n, it becomes a sub 1. A sub 1 is equal to 3 times your value of n would be 1. So n squared, so it becomes 1 squared minus 1. So remember, students, you are going to do is to apply the rule for peptides. So first would be your exponent here. So we have to going to simplify 1 squared. So it becomes 3 times 1. 3 times 1 minus 1. What will be the next step? So the next step to do is multiply these 2 numbers. So 3 times 1 is equal to 3. So 3 minus 1 is equal to 2. So a sub 1, which is the first term of the given general equation. How about if n is equal to 2? So n is equal to 2 given the general equation. So a sub n becomes a sub 2. So a sub 2 is equal to 3 multiplied by n, which is 2 raised to the power of 2 minus 1. Next thing to do is to simplify the exponent. So the simplified exponent, 2 squared becomes 3 times 4. So 3 times 4 minus 1. Next step to do is to multiply the 3 and 4. It becomes 12. So 12 minus 1 is equal to 11. So therefore, the second term is a sub 2 is equal to 11. How about if n is equal to 3? So a sub 3. So a sub n is also a sub 3. So is equal to, based on the given formula here, which is 3 times 3 raised to the power of 2 minus 1. Again, simplify first the exponent. 3 squared becomes 3 times, what is the value of 3 squared? 9. So that is 9. So 3 times 9 minus 1. So multiply 3 and 9, which is 27. So 27 minus 1, it becomes 26. Therefore, 26 is the third term in the given sequence or general equation. And last, what if the value of n is equal to 4? So again, substitute the value of n from the general equation. So a sub n becomes a sub 4. So a sub 4 is equal to 3 multiplied by 4 raised to the power of 2 minus 1. So simplify the exponent. So the value of 4 squared is 16. So it becomes 3 times 16 subtracted by 1. So get the product of 3 and 16, it becomes 48. So 48 minus 1. So the value of 48 minus 1 would be 47. 47 is the fourth term. Therefore, the first four terms of the general equation a sub n is equal to 3x squared minus 1 are the following. We have the a sub 1 is 2, the second term is 11, the third term is 26, and the fourth term is 47. So here is the first four terms of the general equation. Did you get it, students? Students, another example. Find the list of the first 5 terms of the general equation where a sub n is equal to 1 all over n plus 1. So again, we have the same procedure. So let n will be the n term starting from the counting numbers 1 to 5. So 1, 2, 3, 4, and 5. Meaning to say, we are needed for first 5 terms of the sequence whose the general equation like this. So let us start with where n is equal to 1. So we have to go into the substitute from the general equation whose a sub n is equal to a sub 1. So a sub 1 is equal to 1 all over 1 plus 1. So substitute and simplify. So 1 plus 1, it becomes 1 over 2. So a sub 1, which is 1 half. How about where n is equal to 2? So substitute the value of n from the given general equation. So this also the same manner. So a sub 2 is equal to 1 all over 2 plus 1. So 1 over 2 plus 1 simplifies, it becomes 1 over 3. So that is the second term, which is 1 term. How about where n is equal to 3? So substitute again from the given general equation, which is a sub 3 is equal to 1 over your n, which is 3 plus 1. So equal to 1 over 3 plus 1 equals 4. That is 1/4. How about a sub 4? The fourth term, so a sub 4, which is 1 over your n, which is 4 plus 1. So simplify becomes 1 over 4 plus 1 equals 5. That is 1/5. And a sub 5, which is n, is equal to 5. So substitute again from the given equation, that is a sub 5 is equal to 1 all over your n is equal to 5 plus 1. So is equal to 1 over 5 plus 1 becomes 6. Thus, the a sub 5, which is equal to 6. Therefore, the first 5 terms in the given sequence are 1/2, 1/3, 1/4, 1/5, and 1/6. Did you get it, students? Students, here's the last example. What is the ninth term of the given sequence when the ninth term is given by the following general formula? Letter A sub n is equal to n squared plus 2n minus 1. And letter B, a sub n is equal to n times n plus 1 all over 2. So let us start with letter A. So since the given to find the ninth term of the sequence, so let n is equal to 9. Because we are looking for the ninth term, so that represents as the nth term of the given sequence. So since n is equal to 9, substituting from the given formula for letter A, so a sub n is equal to n squared plus 2n plus minus 1. So substitute a sub n becomes a sub 9. That is the value of n. So equals n squared, it becomes 9 raised to the power of 2 plus 2 times So n must be 9. Minus 1. Okay, next students, we are going to simplify this expression. So, the value of 9 squared is 9 times 9 equals 81. So, 81 plus, what is the product of 2 and 9? So, the product is 18. 18 minus 1. So, apply the rule for PEMDAS. So, order which is left to right. So, 81 plus 18 is equal to 99. So, 99 minus 1 is equal to 98. So, therefore, the ninth term of the given sequence whose the general formula is 90. Did you really get it, students? Let us proceed to the letter B, where a sub n is equal to n times the quantity of n plus 1 all over 2. So, a sub n is equal to n times the quantity of n plus 1 over 2. We are going to substitute where the value of n, this is also the same problem. So, n is equal to 9. So, substituting the given formula, so a sub n, it becomes a sub 9. So, a sub 9 is equal to the value of n, which is 9. Multiply by n is also 9. Plus 1 divided by 2. Okay, next. So, apply first the rule for PEMDAS. So, since 9 plus 1 is already inside the parentheses, so a sub 9 it becomes 9 times. What is 9 plus 1? Alright, so which is 10. So 10 divided by 2. After that, so this is multiplication. So 9 times 10, it becomes 90 all over 2. So what is the quotient when the fraction is expressed, which is 90 over 2? The correct answer is 45. So the half of 90, which is 45. Therefore, the ninth term in the given sequence, which is 45 on the general rule. Did you get it, students? So students, that's the end of our tutorial video. I hope all of you are really appreciate the first lesson that I already discussed these topics. This will be held on the preparation for your first lesson in grade 10 in mathematics. Thank you very much for watching. Keep safe from COVID-19 pandemic and God bless us all.